Hello and welcome to my channel. John Smith here, and this video is an introduction to a series of videos on how to make a simple emulator of a retro x86 machine from scratch. And when I say simple, I mean capable and powerful enough to run some operating system like DOS and of course play games. We'll target some of my favorite Sierra's quests like Space Quest, Larry, maybe try something from LucasArts, and also do any kind of other neat stuff. Probably the most interesting thing about this project is that I'll try to disclose lots of information about how x86 machines were built from the hardware point of view. For example, among other things, we'll get deep into hardware components like CPU and PIC and how they interact with each other, how PIT and simple sound works, basic VGA graphics, how to add IDE, keyboard and mouse support on top, and all this might be kinda new and thus interesting even to mature coders. In this particular pilot episode, we'll set up our project and model the first component of our machine. And by the way, do not forget to thumbs up or down so that I'll see if the series is interesting for you and more episodes of this should come or not. Now I think that's enough said for the intro. Let's start our small weekend project. First thing, I'm gonna create some directories for the project and the main source file. For now, I'll include some helper header and write an empty main function. In helper header, I'm gonna place some useful definitions and include most commonly used headers. I'll also redefine data types. That's absolutely not necessary, but I kinda like to do this. Next, I'll make a simple script to build the project. And the basic makefile itself. Writing makefiles is a special kind of magic, and discussing it lies way beyond this video. I'll just say that for now we'll be compiling for 32-bit platforms, that's what that M32 flag about, and link with pthreads library, so that we could use threads. Now I'm going to try to build it to check if I made any errors. And it builds OK. Starting it of course makes nothing, obviously because we have an empty entry point. Also, I'm gonna create another helper header that contains wrappers for functions to work with memory and some other useful memory related stuff. Now we actually can start modeling a component of project's core functionality, and that will be RAM. In fact, this component impersonates not only RAM itself, but the whole address space of the CPU. But I'll just call it RAM anyways. To initialize this component, we'll just call the corresponding function that allocates our heap and specify size. Let's say our machine will have 32 megabytes of RAM. Good enough for retro PC. What RAM is actually used for in the machine? Well, it allows storing and retrieving data. So I'm gonna define some functions that other core components will be using to work with RAM. The number after function name here means the size of data supposed to be read or written. Also, I'll define some overrides to be used with direct host pointers instead of emulated addresses. Now I'll add some more memory wrappers. Include our new component into main source and try to build it again. No errors, that's good. Now, how do we use this component? Imagine our CPU is instructed to store a single word ABCD hex into memory at address p01e00 hex. In assembly, it would look something like this. To perform this, we simply can write inside our emulated CPU instruction RAM write 16 bits at address p0100 hex, the value ABCD hex. Same thing for reading. For example, if our CPU is instructed to read a single byte from some address 1234 hex, we simply call RAM read 8 bits from address 1234 hex. So I think this is it for the first episode. We've just modeled the first component of our emulated x86 machine, and this actually was the easiest one, that works by itself and does not depend on other components. In the next episode we will look into modeling the 8086 CPU for our machine, and that's gonna be a little bit harder, but also much more interesting. So I hope to see you soon, and thanks for watching.